So good morning to everyone in the Western Hemisphere and good afternoon to everyone in the Eastern Hemisphere. My name is Rokom Perme. I'm a PhD scholar from Indian Institute of Technology, Madras. Today I'll be presenting my work on simulation-based assessment of dedicated freight parking slots on travel time and traffic emissions in a commercial street. So next slide. So this will be the flow of my presentation. So next. As covered in Fatai's presentation, freight vehicles act as arteries and veins of economic activities. And they usually perform their loading and unloading activities on car side of the road, where they will be competing for parking space with other vehicles. And these freight vehicles have parking characteristics which are different from private vehicles, means cars. For example, they will resort to double parking if an intended parking slot is filled, and their parking demand is inelastic to the parking policies. So all this creates temporary obstructions and bottlenecks in urban streets. So that therein comes the need for conducting separate studies for freight parking. Next slide. Okay, so we have chosen a study area for our study. It is a 1.1 kilometer section of Sir Tyagaraja Road. The road is located in a very busy commercial street in T Nagar, Chennai, in India. So next slide. So in order to obtain some preliminary idea about the study location, we conducted a pilot survey. We visited the site and we collected details about the roads, and then we also conducted some questionnaire surveys with the establishment owners and the truck drivers. Now the sample sizes are very small, so they are of no statistical significance. However, this questionnaire survey helped us in having in few key inside information about the study area. Also, in order to understand the freight demand of the location, we counted the number of establishments currently under operation, and we found it is 456 for 1.1 kilometer of section. So next slide. So from the pilot survey, we observed that currently there is no designated parking lots for any kind of vehicle. The road is a four-lane undivided bi-directional one. And from the questionnaire, we realized that truck drivers are not willing to deliver the goods for distance more than 150 meters if it is to be done on feet. Currently, there is no nighttime deliveries. And we also observed that double parking practices are quite common in the area, as shown in the picture. So next slide. In order to understand the freight vehicle demand of the study area, we did a small cordon survey. We set up 8 study locations. Those study locations, observation locations, were covering the major entry and exit points to the study section, that road under study. So next slide. The cordon survey was carried out for 14 hours, starting from morning 7 to night 9. In that, we noted the number plate of the freight vehicles and also the time at which that particular vehicle is crossing the observation station. And additionally, we estimated the time required to traverse that section from the data provided by Google. So next slide. So from the cordon survey, we extracted the data, the number of freight vehicles observed along that section. So these are the station-wise, observation station-wise data presented. We can observe that there is no significant freight operation at the time before 7. So from 7, we can see it is increasing and it peaks around noon and gradually it subsides, and after 9 p.m. So next slide, please.
Can you repeat the last sentence? It cut.
Sir, this thing that gradually, sir, in the evening, like after 8, it's reducing, and after 9, there is no freight activities happening in the study that section, sir. Also, we did not have any means of finding which particular vehicle is servicing, delivering goods to which establishment. So we splitted the entire section into 3 subsections. Then based on the data from the cordon survey, We compared the time required to traverse this section and the time the vehicle had taken to cross this section. And based on this, next slide. We obtained the information, we estimated which vehicle is parking in which section, and we also computed the duration for how long that vehicle is parking in which section. So this will enable us in finding which section of that section is having the more demand for the freight. So next slide. Additionally, we collected some secondary data from additionally, we collected some data from secondary sources. We found out that currently there is a pedestrian plaza being constructed as a part of Smart City project. The project has reduced a road to a two-lane road, and the traffic operation has been changed to unidirectional. We collected the traffic flow volume data from Daraso and Company Private Limited, and after the traffic operation details regarding how it will be after the construction is done, it was collected from the local dailies printed. So next slide, please. Using the data from our cordon survey and from the secondary sources, we simulated the traffic operation in the area. As I stated earlier, since there is no designated parking slots right now, we proposed that we can provide parking slots of 5x2 dimension. It is in confirmation with the Indian Road Congress Code 35/2015. After reducing other obstructions, road infrastructure, ramps and all, we estimated that we can provide a parking capacity of 103. And additionally, we proposed that for freight vehicles, we can dedicate the 10% of parking slot for the freight vehicle alone. Also, the traffic information was used as input in this simulation. Next slide, sir. Okay, so the simulation was done for two scenarios: existing scenario and proposed scenario. For existing scenario, again we divided into three sub scenarios. Now, the parking duration which we had obtained in the which we had computed from the cordon survey was used in finding the duration of how long and which class of vehicle will be parking for how long. So in all the cases, the passenger cars or passenger vehicles will be parking for 90 minutes. Freight vehicles will be parking for 20 minutes. And in the existing scenario, since double parking is very common, we had just for the sensitivity analysis, how it changed with the duration of double parking, we used gave 10 minutes for the first scenario, sub scenario, 15 for second, and 20 for third. And in proposed scenario, after providing dedicated freight parking, we observed there was no need for double parking, so that's not applicable in this scenario. So next slide, please. So this is the parking logic which we had followed for the simulation. When a vehicle enters the study area, the software determines whether the vehicle is having an intention of parking. If it is yes, I forgot to add a yes. If it is yes, the freight vehicle, the software will determine which class of vehicle it is, passenger or freight. If it is a freight vehicle, it will again check whether the, for either case, it will check whether the current parking slot where it is intending to park is empty or it is already being filled by some other vehicle. So if it is empty, the vehicle will park immediately there. And after spending some time, it will exit. And for freight vehicles, if it is the parking slot is already full, it will double park. From the study, we found they don't intend to look for the next parking slot. They want to use the nearest one. And for in case of passenger vehicles, they will be cruising for parking so that they can park at the next nearest slot. And after parking for the specified time duration, they will exit the system. While simulating, we used the inbuilt tools for obtaining the parking operations. Wherever we couldn't use the inbuilt tool, we made use of com script in the software. We coded those in the Python, and then we were able to achieve those parking operations. Next slide. So in the simulation, before running the simulation, we had put the parameters which were calibrated from earlier studies. We borrowed those values. it helps us in addressing the heterogeneity in traffic. As I think everyone knows, in India, the traffic is a quite heterogeneous one. So now, as I discussed earlier, we had 3 sub-scenarios for existing one. Okay, sir. 3 sub-scenarios for existing one. Comparing those 3 values from those 3 sub-scenarios with the proposed scenario, we can see, like, even if the vehicle is parking for let's say 10 minutes, there is a significant double parking for 10 minutes. There is a significant saving in travel time. So next slide, please. And in order to assess the environmental friendliness of our proposal, we computed the emissions from the traffic. This is the total emission from all the vehicles. Similarly, like if we are comparing the values of sub-scenario, the emission values of sub-scenario with the proposed one, we can still see in terms of percentage, there is significant saving in the emission with compared to the, when we are comparing with the proposed scenario. All these emissions were estimated using the emission factors from studies which are there in the literature. Next slide, please. With this, I would like to conclude my presentation. I would like to thank Sakti Sustainable Energy Foundation for sponsoring the project. And I also like to thank Center of Excellence in Urban Transport for all the manpower and the resources provided. Thank you. Sir, I'm open to suggestions and questions.